Okay, guys, this is it. The last video, the last assignment of the year, lesson 89 and 102. Now, don't freak out. You're thinking I'm going to give you 2 full lessons. I'm not going to do that. You're just going to do the warm-up and the practice on both of them. But these are 2 lessons that I really need to talk about. There's a whole lot of other lessons, but these are the 2 that I've picked that I really need to talk about. They are due the 19th, Tuesday the 19th, this Tuesday. So you've got the review and test, your last review and test due on Friday. And then these 2 due next Tuesday. I do not have anything due next Thursday, the last day of school, because I know you knuckleheads wouldn't send it to me till like Sunday, and I don't want to be doing schoolwork then, just like you don't want to be. So what's going to happen is, if I don't have everything in, probably by Wednesday at 4. I think I'm going to cut it off Wednesday at 4. Then you'll just get a 0 for it because it's due Tuesday. So get it done Tuesday. Get it to me Tuesday. And then you've got the rest of the summer to go and do whatever. Of course, you've probably been doing whatever right now anyway. But, okay, so this is the last assignment. Do not do them on the same sheet of paper. Yeah. Do lesson 89 on one sheet of paper, do lesson 102 on a separate sheet of paper. Send them separately, even though you're just doing the warm-up and the practice. Okay, so on lesson 89, we are going to be solving what's called quadratic inequalities. So lesson 89 is quadratic inequalities. Quadratic inequalities, which means you've got a quadratic and it's going to have an inequality like this one, 4x squared plus 4x plus 3. Now you're asked to graph these, which I don't want you to do. I'm going to show you what I want you to do if it says to graph them. You're asked to graph these. We don't want to graph them. We're going to be able to factor them, okay? Since it's a less than sign, this is going to be a conjunction. So we're going to write our answer as a conjunction. So I'm going to factor this into x plus 3, x plus 1. So that would give me negative 3 and negative 1. So my conjunction would be negative 3 less than x less than negative 1. That's what you do with a conjunction, okay? That's what you do with a less than, a quadratic with a less than, okay? Let's see a quadratic with a greater than and how that would work. A greater than would be a disjunction. You still factor it though, x plus 2, x plus 3, greater than 0. So this would be negative 2 and negative 3. Since it's a disjunction, x is less than your smaller number or x is greater than your bigger number. So x is less than your small number, x is greater than your big number. These don't have to be graphed. You just put this, okay? So if you have one that says that you need to graph it, something like y greater than x squared plus 8x plus 7, you're not going to graph this. So don't graph. Don't graph. What you are going to do is rewrite it so you can tell whether this is a conjunction or a disjunction. So notice the arrow is pointing to the x squared. Guys, it's still pointing to the x squared. It's still pointing to the quadratic. It's still pointing to the quadratic. So I just flipped everything over. That way I know this is a conjunction and I know how to write my answer. So this would be x plus 7, x plus 1. So negative 7, negative 1. It's a conjunction, so negative 7 less than or equal to x, less than or equal to negative 1. Because you've got the less than signs, okay? That's all I want. Don't graph it. You're not going to graph the quadratic. You're just going to solve them algebraically. This is called solving them algebraically. So we're going to solve them all algebraically. So you'll see stuff like x squared minus 3x minus 7 less than or equal to 3. So you're going to subtract the 3 over and have x squared minus 3x minus 10 less than or equal to 0. So then this would be x minus 5, x plus 2. So that'd be a positive 5, negative 2. It's a less than, so it's a conjunction, negative 2 less than or equal to x, less than or equal to 5. That's it. That's all you have to do. You should know how to factor. You should know how to get your zeros from the factors, and then it's a conjunction, so we write it as a conjunction. If it's a disjunction, you write it as a disjunction. Now let's see, x squared plus 8x plus 16 less than 4. So subtract 4. So x squared plus 8x plus 12 less than 0. So that'd be a 6 and a 2. X plus 6x plus 2. This is -6, -2. It is a conjunction again. So -6 less than x less than -2. Let's see, x squared minus 7x plus 14 greater than or equal to 4. So subtract 4. So x squared minus 7x plus 10 greater than or equal to 0. So that'd be x minus 5, x minus 2 greater than or equal to 0. So 5 and 2. This is a disjunction. So x is less than or equal to the small one, or greater than or equal to your big one. Don't forget the or. If you forget the or, it's not a disjunction, and I'll mark it wrong. It's got to have or, because it's got to be written as a disjunction. So make sure you write it as a disjunction. X squared plus 10x plus 22 greater than 6. So subtract 6. X squared plus 10x plus 16 greater than 0. So x squared, sorry, that should be x plus 8, x plus 2. So -8, -2. It's greater than, so x is less than -8 because -8 is smaller than 2, or x is greater than -2. So x is less than -8 or x is greater than -2. Okay, then you're going to see somewhere you've got x squared plus 4x less than 21, so you need to move that 21 over. So x squared plus 4x minus 21 less than 0. So that'd be an x plus 7, x minus 3, watching the sign. So -7, +3, it's a conjunction. -7 less than x less than 3 is how that works. And then sometimes it's going to look one way. But you can't leave that x squared negative. So what you're going to do is you're going to divide everything by a negative. And because you do that, that flips your inequality. So it looks like a conjunction at first. Oh, I didn't flip my inequality. But then it changes because you divide by a negative. And don't leave that x squared negative. So you want to make sure you change the signs. So x plus 3, x plus 5. That's a -3 and a -5. It's a disjunction. X less than or equal to -5, or x greater than or equal to -3. Let's see if I can find another one where you have to change the signs like that. Let's see. -x squared plus 2x plus 11 less than -4. So you're going to just change all the signs. Then we subtract 4 from both sides. So x squared minus 2x minus 15 greater than 0. So x minus 5, x plus 3. 5 and -3. It's a disjunction, so x is less than -3, or x is greater than 5. That's all I want to see, okay? So on lesson 89, you are going to do the warm-up, which is on page 623. You're going to do the warm-up on page 623. Then you're going to do the practice. Now, you're not going to do the whole practice because I didn't talk about all of it. So you're just going to do practice A through E. So I think that's less than 10 problems. Yes, that is 8 problems. So do a good job on them. Okay? Now for lesson 102. Lesson 102 are those log problems, like I showed you on the review, those really easy log problems. So in lesson 102, you're just solving log problems. You're solving log equations, like log base, what is that base? 5 of x plus 2 equals 3. So just like I showed you on the video on the review, you're going to rewrite this exponentially. So my base is 5, my exponent's 3. My answer is x plus 2. So basically the 3 and the x plus 2 change places. So this is 125 equals x plus 2, subtract 2, x is 123. Make sure the 123 doesn't make that negative or 0. You're good to go. Okay, that's the only thing you have to watch out for. So let's see, log base 7 of x minus 4 equals 2. So that means 7 squared equals x minus 4. So this is 49 equals x minus 4. Add 4 to both sides. So that's 53. So x is 53. Doesn't make that negative or 0, so we're good. Then you can have something like log base 8 of x cubed equals 2. So that means 8 squared equals x cubed. So 8 squared is 64 equals x cubed. Well, you want the cube root of 64, so x is 4. Because you take the cube root of both sides. So x is 4. Doesn't make that negative or 0, so we're good. Let's see. Log base 8 again. X cubed equals 4. So 8 to the 4th equals x cubed. So 8 to the 4th is, let's see, 4,096. And we want to take the cube root of that. That's not what I want to do. Math, cube root, 16. So x is 16. Because you're taking the cube root. Okie dokie. Okay, so you can see them like that. And then you can see them where there's a log on everything. Log x plus log x minus 1 equals log 6. Okay? So you can see them where there's something on everything. Now this is a log base 10. How do I know? Because there's not a base showing. So I follow the rules, laws, properties of logarithms, where when it's addition, I multiply the argument. So I drop the logs off and multiply x times x minus 1 equals 6. Then I distribute x squared minus x equals 6. Move the 6 over, so x squared minus x minus 6 equals 0. So x minus 3, x plus 2 equals 0, so 3 and negative 2. 3 is okay, negative 2 is not, because negative 2 would make that one and that one both negative, so that's not an answer, just 3 is. So that's what you have to watch out for when you're doing ones like this, okay? Now let's see, let's try log x plus log x minus 2 equals log 8. Log, and then log x minus 2 equals log 8. So again, x times x minus 2 equals 8. X squared minus 2x equals 8. Move that 8 over. X minus 4, x plus 2, 4 and negative 2. Negative 2 won't work because it'll make both of those negatives. So just the 4. Then if they give you inequalities, it works the same way. It may say to use a graphing calculator. You don't need to. You just follow your rules, laws of logarithms. When it's subtraction, you make a fraction. So this would be 12x over 4 less than 25 because all the logs cancel. Every term has a log, so all of them cancel. So this is 3x less than 25. Divide by 3. Doesn't change your inequality. So x is less than 25 over 3. That's all you do. X is less than 25 over 3. Log x minus log 5 equals log 17. So x over 5 equals, this is 17, not 77, 17. So then I multiply both sides by 5. So x is 85. You don't need a graphing calculator to do that. You do it just like that. You do not need a graphing calculator. Don't use a graphing calculator on it. Remember, if it's subtraction, to make a fraction. So let me do another one where it's subtraction. This is actually an equals one. So x over 9 equals 12. Multiply both sides by 9. So x is 108. Then there are times you're going to see something where there's not a log on everything. So for example, you're going to see log x plus log x plus 9 equals 1. So you follow your log properties of logarithms on this side. So x times x plus 9 equals 1. So this is like a log, okay? It's like a log now. Now write it exponentially. So 10 to the first equals x times x plus 9. It's the easiest way to do that. So then you've got 10 equals x squared plus 9x. Move the 10 over. Factor x plus 10, x minus 1. So negative 10, positive 1, which negative 10 won't work because it'd make both arguments negative, so your answer is just 1. But that's what you do. Follow your rules log of logarithms on this side, then rewrite exponentially. Your base is 10 because there's not a base there. And then your exponent is 1. And it equals the argument x times x plus 9. And then if you see it with the inequality, you do it the same way. So this is a subtraction, so we make a fraction. Greater than or equal to 1. Nothing drops off that. So from here, because this is still a log, because I can't drop the logs off because there's not a log there. So I rewrite it exponentially. So it'd be 10 to the first greater than or equal to 45 over 3 should be. This is 15. Right, so again, you switch the exponent and the argument. Just switch. Do not switch that inequality. So I divide by 15. So that's 2 over 3. So x is shows to be greater than. So I guess, okay, so let me come back up here. Right here, when you do the 10 to the first, you do need to change your inequality. So this would be 45x over 3. You do need to change that when you rewrite. So my base is 10, my exponent's 1. So you do need to rewrite. If it's pointing to the exponent, it's got to stay pointing to the exponent. So do flip that. Didn't think you had to, but I was wrong. So we divide by 15. It's still 2/3, but x should be greater than or equal to 2/3. Okay, so that is lesson 102. So on lesson 102, you're going to do the warm-up, which is on page 714. And you're going to do practice. I've got F on there. You're just doing A through E. I don't want you to do F. You're just doing A through E on that. And this is due 519 with lesson 89. So you've got lesson 89 and lesson 102, just the warm-up and practices on both of them. So it's like 10 problems on this one and 8 problems on the other one. But lesson 89, lesson 102, they're due next Tuesday. It's your last assignment. So hopefully next year, prayerfully next year, I will see y'all in pre-calculus. Some of you may want to take honors pre-calculus, which I'm not teaching that. So I'll teach the regular pre-calculus. So hopefully most of y'all will take me and I can actually see you again. But have a great summer. Do great on your last test, on test 18 or review 18. Do great on that so you can end with a good grade and a good average for the semester. Have a great, safe, healthy summer. And like I said, prayerfully, I will see you in August.